We will solve the next problem on isometric views. So we'll see the question, type image attach. Okay, so the next question is on the screen. If we consider this question, again we are using first angle projection method. We have front view and then we have on right hand side LHS view, left hand side view. Since we have left hand side view, the side view will be drawn on left plane and front view will be drawn on right plane, and this we can also verify by looking at the position of O origin, where since the O is on left side for front view, the remaining dimensions are on right side, so the front view will be on right plane. Same way, left hand side view, origin is on right bottom corner and the rest of the dimensions are on back side, so basically it will be along this plane. So we will quickly calculate the length, width and height of this diagram. So text length into width into height. So the total length is 40, 50, 60 into width, we can see in the side view it is 40, into height we can see in the side view 100 plus this outer radius which is 20, so 120. So we need to create a box of the dimensions which have been mentioned over here. So I'll turn on isometric snap, DS enter, or you can click over here. So isometric snap, OK. Click and turn on ortho mode. Select the projection layer, select line. Now since the front view is on right plane, we will draw 60 length and 120 height on the right side, right plane. So we'll draw that. This will be 60, height is 120, 60, 120. L enter. The width is 40, height is 120, 40, spacebar, F5 to change the plane. The length is 60 and the width is 40. Escape. Now I need to move this box, so I'll turn off ortho mode and iso snap. Select the lines of this box, M enter. Okay. Now next we will understand the question. So if you see this box on front view, which is right plane, since O is on left side, O will be over here and the front view will be drawn on right plane, and left hand side obviously it will be drawn on left plane. So basically here we have some 10 millimeter, then there is a dome shape type structure, again 10 millimeter. Now this has a length, the width is 40 millimeter. So I'll turn on isometric snap and ortho mode. Select the object line, outline, click line. This length is 10 millimeter, 10 enter. Then this height has been mentioned over here 30 millimeter. So F5 to change the plane, 30 enter, spacebar, spacebar. Now this height has been shown from this point to this will be 40 millimeter. So 40 enter, escape, select the projection layer. Now from this point the center will be 20 millimeter. So select line from this point, 20 enter, 20 enter, escape, select outline, make current, EL enter, click iso circle, specify the center, and we want the circle on the right plane only, that is front plane, and the radius is 20, so 20 enter. Extend the center line, EX enter, escape. Now next we'll trim the bottom part, TR double enter, trim this. Now next in the front view, here you can see in the side view there is a circle, so this circle will be over here. Same way there is a semicircle like this, so semicircle will be over here, and this face is basically 10 millimeter away from left plane. Okay, so we need to remember that. And from the side view, here you can see a circle is there, and in the front view you will see that the hidden line, if you trace it, basically this hole is a this circle is a hole which is a throughout hole. So if you see from the front view, there will not be, that hole will not be visible, that is why it is been shown by hidden line over here. So what we understand from here is, at a distance of 10 millimeter inside we have this hole. Okay, so I'll select the projection layer, click line, from this point inside we have 10, so 10 enter, and the height we need to reach the top plane or maybe the center, this part. So what is the height, we'll calculate that. Total from the bottom to top is 120, height we have already found out, 120 millimeter. So 120 millimeter is the height and the radius is 20, so 120 minus 20, and we have already reached this point. This point is at a height of 40, so 120 minus 20 minus 40, we will get 60. So from this point, which is at a height of 40 millimeter, to the center of the hole, the height will be 60 millimeter. So select the line, from here I'll draw this at 60 millimeter. Now the center, if you see the center in the side view, the center is at 20, so I'll change the plane, F5 left plane, and 20 enter, escape. Now change the layer to outline, EL enter, click iso circle, specify the center and specify the radius. The outer radius is 20 millimeters, so 20 enter. Again EL enter, click iso circle, specify the radius. The inner hole radius is half of diameter, diameter is 30, so radius will be 15. 15 enter. The vertical height, if you calculate from this point to the center of the hole, is 60, and the height of this feature which is coming out, it's 20. So from this point to the bottom side we have to draw a line of 40 millimeters. So L enter, from here I'll draw 40 millimeter line, 40 enter, and join this point, escape. Now the next part is we'll copy this part on the back side as well. Select this line first, CO, enter, escape, L, enter, from here 30 and F5, this distance is 10, escape. Now next, the hole and this feature is having the width or the length, you can say, in the front view it is 40 millimeters. So I'll select this circle, I'll select this circle. Before that we will trim this part, so EX, enter, extend this line, TR, double enter, trim this part of the iso circle. Select this line, CO, enter, this will be the base point and this will be the second point, escape, L, enter, join this line. Now we will offset this feature and the hole by a distance of 40 millimeters. So we need to copy it. So CO, enter, this is the center and we have to move in this direction by 40. So 40, enter, escape. Now the height we have already found out, that is 40. So from here F5, this will be 40 and then join it with this point, escape. Next, L, enter, quadrant to quadrant, join this. Quadrant is shown in diamond shape, escape, TR, double enter, trim this part. Now since this hole, the distance is more 40, this hole will not be visible. Okay, if the circle, if this width is small like 10 millimeter, it might be visible over here. So I'll delete this circle as well. Now since here we have a slot, here we have a slot, so this edge will be visible. So I'll enter, F5 to change the plane, TR, double enter, trim this part, escape and delete the remaining line. Now if you see the left hand side view, this part is remaining. Okay, we have already shown the slot. Here you can see in the front view there is a slot and this slot is throughout. Here you can see the hidden line. If you take the projection of this slot, here in the left hand side view, here you can see the hidden line, means this slot is throughout. Next, in the side view, here you can see one feature. What is the length of this line? We will calculate that. So 40 half is 20 and 10 half is 5. So 20 minus 5, 15. So this length will be 15 and the height is 20. So L, enter, this is 15, height is 20, enter. So we have got this bottom line. Next, escape. Here you can observe there is a line. Why is this line drawn? Because here we have a vertical plane and then we have a slant plane. So wherever plane changes, we need to draw a line. So this will be the line. Now when we see from the front side, I have drawn this vertical line. So this line I have drawn, I need to join this horizontal line I have to draw. So L, enter, from this point change the plane, F5, extend it slightly, trim the remaining part, TR, double enter, trim this, escape. Now again here you can see the plane changes. This is vertical and this is horizontal, so we need to join a line, L, enter. Next, the thickness of this feature is 10 millimeters. So L, enter. We'll start from back side now. Again this distance will be 15, so 15, enter. F5 to change the plane. Height is 20 millimeter, 20, enter. And back side, click over here, escape, TR, double enter, trim this part. Now here you can see again there is change of phase from horizontal to vertical, so L, enter, draw a line over here, escape. Now if you see the left hand side view, this is the left hand side view. Here we have this line which is shown over here. This is one more line which is shown over here. And basically in the front view, here you can see the triangle. This triangle is indicated by these three lines. So this is the triangle. Here this angle is not required in isometric already, as we know. I'll quickly go out of the isometric mode, select the projection line. If we check the angle over here, the angle is 30 degree. Here also angle is 30 degree. So we cannot draw the angles in isometric view directly. We need to draw a separate figure over here and then need to transfer the distances. Anyway, all the distances were mentioned over here, like the width is 10, so this is the 10 width, this one, and the height in the front view is 20, so this height is 20. So this angle was not necessary. Now we'll do the final checking. The front view, origin is on left bottom corner. This is the origin. Since the origin is on the left bottom corner, the rest of the front view is drawn on the right plane. Then left hand side view is drawn on left plane. The hole we have shown complete hole throughout. Okay, if we see from the front view, we will see a hidden line. The hole is not visible. In the side view, the hole will be visible, whereas this slot is visible in front view, and in side view, if you see from this side, it will not be visible. That is why here we have this hidden line. So with this we have completed this problem. Now what we will do is we will quickly give the numbering to all the problems. So I'll change the layer to outline, select the circle. Suppose the radius is 5. Select text. This is problem number 1. Escape. Turn off ortho mode. Place the numbering exactly at the center. Escape. This is problem number 2. This is problem number 2. So circle, text, I will change the text height to 5. Here also I'll change the text height. Select this, click over here, 5, enter, escape. Now just adjust it, select. Same way question number 3. So I'll select this, CO, enter, escape, double click. This is 3. Now the only thing remaining over here is the name box, so which I have already made and kept it in block. So I'll insert it, insert name block, place over here. Now you can give the title of the sheet by selecting the text. So text isometric views, escape. Change the text height. Place it properly. So we have completed the sheet. Now if you want to hide the outer box, you can turn off the projection layer. If you want to take the print of this, I'll move the questions away from the border. So M, enter. M, enter. Control P. Select Microsoft Print to PDF. Select for internal assessment paper, you can select A4. Now I am selecting A3, so click A3. Plot object line weights should be turned on. Here basically we can see less options. If you want to get that option, you need to click over here. So plot object line weight should be on. Landscape. What to plot, we will select window, and we won't select the rectangle because I want the border also on the paper. So slightly outside I'll zoom and take the help of this grid lines. I'll draw a rectangle like this. Then center the plot, apply to layout, click preview. So this is the isometric view sheet. Now you can save it as PDF. Plot, give the name to PDF, isometric view, and save it. Now you should be careful when you go to the layers. Here there is an option to turn off the print. So even if the projection layer is on, projection layer is visible, if I turn off this option, okay, it is plot option, so the projection layer will not be printed. So if I press Ctrl P, and if I see the preview, then also you won't see the projection lines over here, okay. But if I turn on the printing option over here, okay, and the projection layer is also on, press Ctrl P, click preview. Now you will see the projection lines as well, okay. So we don't want the projection line, it depends. In our case I am not showing the projection lines. So this is it for this video. Thank you.